In this video, we'll be talking about the basics of constructors and destructors. First, let's review what objects are. Objects are entities that encapsulate both data and behavior. So each object has some member variables that define its state and some methods that allow us to change that data and interact with other objects. And of course, for each object, we need to know the layout of that data and the interface that we can use to modify that data. And both of those are defined by the class of the object. And classes are going to be a big part of what we discuss today, as constructors and destructors are both parts of a class. So what is a constructor? Well, it is a method within a class that actually sets up the object for us when a new object is created. A class's constructor will get called automatically anytime a new object of that class is created. And in practice, the constructor's primary responsibilities are to initialize member variables and make sure that the object in general is set up in a valid state. So let's pop over into CPP shell and take a look at what constructors look like in our code. Here's some code that declares a new class called example. And you'll see that example has one member function, and it looks a little strange. It looks like it doesn't have a return type, and it looks like its function name is the same as the class name. This is what we're talking about right here. In fact, this is the constructor. You can always identify it because it will have the same name as the actual class itself. Like any other function, it has some of the standard parts. We've got the parameter list enclosed in parentheses, and we've got the body of the constructor function in between curly braces. But there is another part of a constructor that you won't see with other functions, and is pretty common and important, so I want to introduce it to you here. It's called the member initialization list. See, we really don't want to be using uninitialized variables anywhere in our C++ code, because we don't know what data might be in those variables. All of our programs are using space on our computer that another program has already used before, and who knows what it left in that space. So in order to avoid using uninitialized variables, the class has to initialize everything before the body of the constructor starts. Of course, if our constructor is the one responsible for initializing variables, but we have to do it before the body starts, but we can't have any code outside of the body for the constructor. How are we going to do this? Well, that's where the member initialization list comes in. This part of the constructor actually sits in front of the constructor's body, and it tells the computer how to initialize certain member variables before the body starts. Here's what a member initialization list looks like. I've gone ahead and added two member variables to our example class, an integer called exampleData1 and a double called exampleData2. After the parentheses that define our parameter list for our constructor, and before the opening curly brace of the body, we see the list of member variables again. We start with a colon. That's just the syntax that tells the computer we're starting a member initialization list. And then we have a comma-separated list of initializers. Each member of the list has the name of the member we're initializing and then the actual value that we're initializing it with. So this first one initializes exampleData1 with the value 4, and then we initialize exampleData2 with 5.6. This is a good way to give our members default values, and those members will have those values as soon as we start executing the body of our constructor. Another useful thing we can do with constructors is actually have more than one. Just like we can have functions that have the same name but different parameter lists, we can have constructors that have the same name and different parameter lists. This is useful so we can set up our object in multiple ways depending on the data we have at hand. Here's another constructor we might have for our example class. It starts off with the same syntax, using the name of the class as the name of the constructor. In this case, we're going to take in one parameter. We're going to say we already know what data1 should be, so we don't need to use its default value. In our member initialization list, we're going to set example data1 to data1. And in this case, our class has a rule where data2 always has to be 1.6 greater than whatever data1 is, and we can reference that value directly in the member initialization list. So example data2 is initialized with data1 plus 1.6. So that's what constructors look like when you see them inside of a class. But what does it look like for them to actually get called? Let's pop into our main method and call a few constructors. The simplest way to call a constructor is to declare a variable of that type. When we were talking about variables, we mentioned that there would be extra syntax required for initialization, usually with an equal sign and a value on the right-hand side. Objects are not allowed to exist in an uninitialized state, so whenever we declare a variable that is of a normal object type, the constructor has to get called behind the scenes so that object is initialized. The biggest drawback for this style of syntax is that it only works when your object has a constructor with an empty parameter list. Now we happen to have one up here, so that code will work. But if we didn't have a constructor with an empty parameter list, this line would fail to compile. Luckily, there are other ways for us to more explicitly call the constructor and pass in any input that we need to give it. And here we have yet another object of the example type. This time we're calling it E2, and we're giving it a more traditional initialization style, the equal sign and the expression on the right-hand side. And in this case, on the right-hand side, we're calling the constructor, for example, and giving it the value 2. So this line will call our second constructor that actually takes in data 1 and initializes our object based on that value. And here's a third syntax for calling constructors. There are a few of these. In this case, we again start with the type, example, the name, in this case E3, but in this version, we jump straight to the argument list for the constructor. Again, we're calling the version that takes in an int here, and we're giving it the value 3. You'll see this syntax less frequently because it can cause a problem known as the most vexing parse. To see that, let's declare E4 and use the same syntax, but use the noargs constructor, so we give it no input. Now this might look totally fine to you. We have the type, we have the name, we have the argument list inside parentheses. Unfortunately, the compiler is just another program that has to follow rules to figure out how to parse our code, and in this case, its rules actually say that E4 has to be a function with the return type of example and an empty parameter list. So for a long time, this was a problem that beginners in C++ ran into pretty regularly. And so C++11 introduced another style of syntax for calling constructors to avoid this. So these examples, E5 and E6, show off this new syntax. Basically, it just replaces the parentheses with curly braces, and you can use that both for the short form and the long form syntax. Now there are some specific differences between the curly brace version and the parentheses version, but they won't impact most of your beginner level code, and so we won't worry about them for right now. For now, just know that all of these lines call the example constructor with different inputs. And whenever you see code like this, now you know that this is just calling a constructor inside of the example class. This is the basics of what a constructor will look like in a class. Of course, our examples here don't do anything in the bodies of these constructors because they're pretty simple. If you were to look into the code that powers our training robots that we use in class, you would see that the RoboJackets class has its own constructor, and that constructor is a little bit more complicated. It follows the same syntax, but it actually does some things in the body. And the kinds of things you do in constructors include turning on various sensors inside of the robot, checking whether or not motors should be enabled based on whether the robot is charging or we are running off battery, starting any background tasks. In the case of RoboJackets, there's a background task that monitors the encoders, and so that gets started inside the constructor. And basically, they're just making sure the robot is ready to use. And now let's talk about destructors. And don't worry, compared to everything we can do with a constructor, destructors are actually simpler. A destructor is called anytime an object's about to be destroyed, and its primary purpose is to clean up anything the object was using that can't automatically be cleaned up by the computer. So we just talked about how the constructor of the RoboJackets class that we use on the training robots does a bunch of things. It starts up sensors and it starts up background tasks and things like that. Well, the destructor is the opposite. This is the place where the RoboJackets class gets to shut all those sensors down. It gets to make sure that that background task is properly closed, and in general, it just makes sure that our robot is cleaned up and reset, and that all the extra hardware is powered down. Now let's go look at what destructors actually look like in our code. We're back in our example class, and I've given it a destructor. You can see it right here. It looks like another function, but in this case, the name of the function is not just the name of the class. We've stuck a special character in front of it. This little squiggly character is called the tilde, and you can find it on most US keyboards as the shift character to the left of the 1 key. Destructors can't take any input, so the parameter list will always be empty. That also means we can't have more than one. Every object will only have one destructor. And there are no other special parts of a destructor, so this is really it. Our example doesn't do anything because it's simple, but this body is where the RoboJackets class would do all the cleanup we discussed earlier. Now, when do destructors get called? Well, whenever the variable is destroyed. We've talked before about how variables get destroyed when their scope ends. And we'll have more to say about object lifetime later, but for now, just remember that when we have variables declared in a scope, and that scope ends, those variables will get destroyed. And if those variables happen to be objects, their destructors will get called. And that's all we've got to say about constructors and destructors for now. As your code gets more complicated, you'll get more practice writing and reading constructors and destructors. For now, though, you've hopefully learned enough to recognize them in code and remember what they do.